Good morning, all of you. So, in today's class, we are discussing about gelatin. I had told you I'll tell you how to extract gelatin and how we preserve and use it for the further preparation of the capsules. So, we'll see one by one. Uh, Gelatin. It is a heterogeneous product obtained by hydrolytic extraction of animal collagen. The source of gelatin include animal bone, hide portion, and frozen pork skin and white connective tissue. So these are the sources of extracting gelatin, and it is a heterogeneous product which is extracted by hydrolytic process. Okay. Types of gelatin. We already know hard gelatin and soft gelatin. These are the two types of gelatin available. The bone gelatin gives tough and firm film which tend to be hard and brittle, which we use for hard gelatin. Soft gelatin is pork skin gelatin, gives clarity and plasticity, which we use for making soft gelatin. So two types of gelatins are available, which is the basic gelatin. Pork skin is basically used to prepare soft gelatin, and uh, bone gelatin is used to make hard gelatin. But in basic gelatin, when we extract from any animal, two types of gelatins are available, type A and type B. So type A is obtained by acid hydrolysis of pork skin, for which isoelectric point is near pH 9. So type B is obtained by alkaline hydrolysis of bones, and its isoelectric point is between 4.4 to 7. So in this slide, you have to remember two things. Type A, acid hydrolysis, isoelectric point is pH 9. Type B, alkaline hydrolysis of bones, isoelectric point is 4 to 7. What are the ideal properties of gelatin? It is non-toxic. It is readily soluble in biological fluid at body temperature and is digested by proteolytic enzymes. As we already know, it is very easily digestible. Even in water, it gets dissolved. In biological fluids, definitely it gets dissolved with a normal body temperature. It produces a strong, flexible film as its plasticity itself is very strong. We get very flexible film when we extract. The wall thickness of hard gelatin capsule is about 100 micrometer. So the thickness of the hard gelatin is 100 micrometer. This you don't have to remember. If you remember, well and good. It has gelling power, forming thermo-reversible gel. This we will see when we study bloom strength. I had told you I will tell you what is bloom strength. I have not come to that topic yet. I will tell you what is thermo-reversible gel or what is bloom strength. Okay. Preparation of gelatin. Now, how we prepare this gelatin? So, first we take dry bone. If we are extracting from dry bone or calf skin or pork skin. So, we'll see one by one. What is the process when we are extracting from dry bone? If it is a dry bone, 5% of HCl, 10 to 15 days, we will have to soak it or put it in 5% of HCl for 10 to 15 days. Then we do lime wash with 10% till 4 to 8 weeks. And at last, we have to wash it to adjust its pH. See, process, how it actually happens, it is very lengthy process, but to write it in a short form and how it actually happens. Say, for example, if I have to tell you how we are going to make, say, Ampules. Okay, so how they prepare ampules, how we fill parenterals in them, how we seal them, how we pack them, and how we market them. The entire thing is a huge process. But as we study one by one, we know how we do it. But here, preparation of gelatin or extraction of gelatin, it takes weeks together and days together to bring it into a gelatin form. So these steps are just to tell you how we get a solid or how we get a gelatin form in our industry to convert them into capsules. So this is the process for if we are taking dry bones. Next, calf skin. We need to wash it as it is a skin. Then lime 10%, we have to keep it for 6 to 12 weeks. Then again water wash for 10 to 30 hours so that it takes away all the lime and unwanted things. We'll stop there because altogether last 5 steps include. So this is till water wash 10 to 30 hours till here, from calf skin till here, dry bone, wash to adjust pH. Now if you are taking pork skin, then initially wash it again 1 to 5% HCl for 10 to 30 hours. That's it, because it is more softer compared to dry bone. Here also we are using 5% HCl only, but we are going to keep it for 10 to 15 days. But here 10 to 30 hours would be sufficient as the skin is soft. And at last, acid removal, or we can also call it as water wash. So after washing and adjusting pH, all these animal products, then comes for extraction, where we take out the gelatin. We filter it, remove all skin debris, unwanted things, we cool it, then sterilize and get it dried. Then we get it in a gelatin sheet or gelatin form. So that gelatin sheets or gelatin is then converted into capsules, soft or hard gelatin. We will see how hard gelatin is made from the raw gelatin and how soft gelatin is made again from this raw gelatin. Do you have any doubts in this slide, or is it okay?
Okay, ma'am.
Sorry?
Okay, ma'am.
Okay, thank you. So yeah, this is Bloom strength. I'll just read it, but you'll not understand it completely because even I did not understand when I was studying Bloom strength in college. I had to see some videos to understand how we uh, check its Bloom strength or how we check gelatin's Bloom strength. But to write in the exam, you will have to write it in this way only. But uh, for me, just by hearting definition will not help in the exam. We need to understand how it works. Only then I can make my own definition. Otherwise, you will have to by heart if you don't understand how actually it works. But for now, I'll read out its definition and I will show you with video how we check Bloom strength. So this is a test to measure strength of the gel or gelatin. Everything has a strength. Why we need to check its strength? Because we are going to fill certain dosage form into those uh, shell or into gelatin. So we need to check its strength, whether it can take minimum shocks, whether it can take turbulence while sealing, while packing, while filling. There will be certain pressure applied on the gelatin capsules. So we need to check what is the strength of the gelatin. The test determines the weight in gram needed by a specified plunger which has a diameter of 0.5 to depress the surface of the gel at specified temperature 4 mm without breaking the gel. The result is expressed in blooms. Bloom strength in range of 150 to 280 gram are considered suitable for capsule. The higher the bloom, the stiffer the gel. So this number I had told you before also, the range should be between 150 to 280. This is the range and we write it in blooms or in here in grams, but we express it in blooms. So from here to here, we use plunger to depress the surface of the gel with specified temperature. How it actually happens, I need to show you in the video. Only then you'll understand this line. And at last, the higher the bloom, the stiffer the gel. That means if more the number 150 to 280, if it goes towards 280, then we get stiffer gel. If it is coming towards 150, reducing, then we get softer gel or softer gelatin. Gelatin, sometimes it is also called as gel because it looks or its consistency is near to gel. That is why. Is it okay? Did you understand the basic thing about bloom strength here?
Ma'am, why the strength is in grams?
Yeah, I'll tell you because you have to see the video how plunger is used to check its strength. Um, See, angle of repose is in degree, correct? We measured
Yes,
it in
ma'am.
a degree, 45 degree, 25 degree, 30 degree, correct?
Yes, ma'am.
Yeah, hardness we checked in kg, correct?
Ma'am, why can't we check it in density or viscosity if we are checking the strength of it?
It is not typical gel to check its viscosity. See, viscosity will not give you strength. If you think like that, what would be the viscosity of glycerin? What is the viscosity of honey? If viscosity is higher, the strength is more. No, it doesn't work like that. Strength is something that, see, there are two types of strength we have to check here and we have to understand. Have you heard about tensile strength?
Yes, ma'am.
Yes. How we check it? For what we check it?
Ma'am, for its hardness or property, whether it will, it's,
For
ma'am, to check how hard it is or how stable it is. Check the strength of the.
okay, we basically check with the tapes or stickers, or if anything, we have to stick it, adherence, films. For all these, we check tensile strength to check its flexibility and adherence. Okay, here also, if we have to check its strength, strength is different from viscosity and density. Anything which tells about mass and volume will give you the density, but it is not necessary. Viscosity is very high, then it will have good strength, not necessary. That is why checking bloom strength is different to check viscosity and tell how stable it is. Honey has more
Ma'am, density.
viscosity than glycerin, then it is more stronger, or it has more strength.
Ma'am,
Yes, I'm not able to hear Jatin.
ma'am, density also we can't take.
No, density is something which is mass and volume, to see where it stands in the bottle or how denser the product is. To check that, we do density. We check the density of oils, we check the density of organic liquids, inorganic liquids. That is because how denser it is. To formulate something, we should know, if we are mixing two things, what is the density of it, whether it stands above the liquid or below the liquid, where it is. To check that, we see density. But to check the strength of the product, it is different. If, according to you, then honey has more strength than glycerin? No, no. We don't check it like that, no.
Yes, ma'am.
Yeah, we check viscosity because, especially in suspension, we check viscosity to see whether it can keep the particles in place. Or when we shake, if viscosity is higher, then the particles are more stagnant when compared to less viscous liquid. If I put sand in water and shake, within few seconds it will settle. But if I put same sand in honey and shake it, it will stay in a place for longer time and it will take more time to settle down. Agree?
Yes, ma'am.
Yeah, that is a sense of viscosity what we talk in formulations. But here, checking strength of gelatin is different. I'll show you the video, then you'll understand how we correlate strength of the gelatin to um, uh, to viscosity, or how it is different from viscosity and strength. Okay.
Ma'am, like for other than gram, force per unit area we can't use to denote strength.
That we would have used in hardness tester also, no?
Yes, ma'am.
There also we used force only.
Yes,
Yes.
ma'am.
Yeah, we didn't use because it was the amount of pressure we used to crush the tablet. Correct. And we were checking that pressure in kg. How much kg it took to crush a tablet. That we called it as a hardness of the tablet. Here also, how much gram it will take uh, to collapse the gel or to break down the gel. How much gram it will take. Here kg is not required because gelatin is very soft. That's why we use gram. And how much gram it is used to collapse the gel or shape of the gel.
Okay, ma'am.
Okay. Okay, so we have already studied what is capsule. Can anybody frame a definition and tell me what is capsule? Basic definition of capsule.
Ma'am, it is capsule is a form of oral dosage form which consists of a body and a cap, and the drug is embedded inside or kept inside the body.
Hmm. Okay, correct. If in exam they ask define capsule, see that you define both hard gelatin and soft gelatin. You defined hard gelatin and you said it has cap and body. How about soft gelatin? You just missed adding those sentences, no? So in exam when it is asked define capsule, define hard gelatin capsule, then you can write about hard gelatin. Then if they ask vague questions like only define capsule, see that you write both hard gelatin and soft. Okay.
Okay, ma'am.
Yeah. Advantages and disadvantages of the capsules also we have discussed in previous classes. I just thought of keeping the slides to make you recall. Can anybody tell me two or three advantages and disadvantages? Two or three. First, tell advantages.
Ma'am, fast acting.
Okay. Fast acting compared to what?
Tablet.
Okay.
Comes in different size to give different amount of drug.
Yes, this is proper advantage. Telling faster than capsule would not be completely correct because we prepare immediate release tablets also, which is more faster than capsule. But which you told second one, it comes in different shapes and size. Yes, it is an advantage. Then
Ma'am, can be used to administer liquids, semi-solids, many different types of dosage form.
yes, yes, correct. Good. Any other advantage? Colors are not required, coating is not required, flavors are not required. Process manufacturing steps are very less when compared to tablets. Tablet we have to punch, here only it is filling, we have to make granules there, here not necessary that we have to make granules. So these are the advantage. Any two disadvantage?
And hygroscopic cannot be filled into capsules.
Okay. Okay.
Ma'am, effect of moisture is more on capsules.
Effect is more. What does that mean?
Ma'am, like drug can be easily become in contact with the moisture and get
Mm. Ah,
destroyed.
that is called hygroscopic. Hygroscopic liquids or materials cannot be added into capsules. Correct. Any other disadvantage?
Ma'am, solutions which require previous dilutions are also unsuitable because they cause irritation in the stomach.
Okay. Okay. Then any other? If you want to modify the dosage forms and if you want to put like effervescence, if you want to make immediate release, if you have to coat like enteric coating you want to do, then it becomes little challenging when we want to make a capsule. And it can make many disadvantages and advantage as we start covering up different chapters like parenteral semi-solids. So more number of advantages and disadvantages you will able to quote. For today, if you can at least make 5 advantages and disadvantages, good. So next, components of hard gelatin capsule, this we have already studied. With examples we have studied, so I'm going to skip the slide. Yeah, this is very important slide which I want to discuss today. Uh, these are the steps you have to remember in this flow only. You cannot mix up, or you cannot put the sixth one first and fifth one first, or you can't mix up them. You have to write it in this flow and in this serial number. So the first step is dipping. 1 second, give me a second. Okay, so the first comes dipping. This process is how we make gelatin capsule, and this is for hard gelatin capsule. Not filling inside, how we literally prepare these shells, cap and body, how we prepare and how we get them from the supplier or industry. So first process is dipping, next spinning, drying, stripping, trimming and joining, polishing, sorting and printing. So let me switch on the video so that I can explain you better. Okay. So first is dipping. The gelatin is in solution form. When gelatin is in solution form, if I dip my finger in gelatin, and the gelatin fluid will just adhere to my finger, correct? This is dipping. Just dip the pins. I am showing my finger here, but we'll have different pin plates where on the plate, say this is the plate, and here many pins will be there, and we just can dip it into the gelatin solution, and all the pins will be covered with the gelatin. All the pins will be covered with the gelatin. So this is the first process called dipping. Understood?
Yes, ma'am.
Okay. Next, we need to spin those pins. You have dipped it, then I have to rotate these pins so that extra amount of gelatin which is adhered to the pin it will go out. So we need to spin it. Spin it, and proper adherence of the gelatin to the pin will takes place. Okay, this is the second step. Clear?
Yes, ma'am.
Okay. After we have done this, we are going to dry it. Have you ever played with Fevicol at home?
Yes, ma'am.
With Fevicol, after it gets dried, you like peeling it off and you'll get fingerprints on that.
Yes, ma'am.
Yes. So here
Yes,
also,
ma'am.
first we dipped it, spinned it, we dried. After we dry, when I take it out, the nice shape of, like this, the shape of capsule will come out after I dry it. So what I take it out from the pin is stripping. Okay.
Okay, ma'am.
Okay. Next, after stripping, we cannot tell that, say this is the capsule. You can see the circumference of this cap. Let us call it as capsule for today. It is so nicely cut. Sometimes what happens after dipping, trimming and stripping, this end part of the capsule body or cap might have irregular endings. It might have irregular endings. So what I have to do, I need to trim it. I need to cut it. Correct? After trimming, I got cap and body. So I will join them. Cap and body are joined. After joining, does the job get finished? No. We want glossy, no derbis on it, nothing on it. We want nice, shiny capsules, right? So that is why we need to polish it. We are going to polish the capsules. At last, we need to sort it out. Sometimes the capsules, when we are doing it in the large scale, sometimes it will, some are irregular shape, some are crushed, some are broken. So we don't want such damaged capsules. Then we need to sort it out. Nowadays we have got machines to sort out capsules also. We don't have to do it manually. The machine itself will detect which is the wrong capsule or which is the damaged capsule, and it will throw away by itself. At last, if necessary, if the company is demanding, then we need to print on the capsule. So this is the process of uh, making hard gelatin capsules. Any doubt here? Any doubts here?
No, ma'am.
Okay, I'll show you the picture soon after I finish these slides. So components of the soft gelatin also we have studied what all we put into soft gelatin and hard gelatin. The only difference between hard and soft is in soft gelatin, the amount of plasticizer varies. So what all we can fill in the soft gelatin also we have discussed: liquids, solids like paste, granules, pellet, suspension, and liquids like immiscible, miscible, volatile, non-volatile liquids. Yeah. So manufacture of soft gelatin shell. So manufacturing part, we still have to discuss by showing the machine, how it looks like, and how actually we fill the capsule, and we fill the soft gelatin capsule. That part I will take it tomorrow. Sorry, day after tomorrow. And I will show you with machines and videos how processing happens. So these are the names of the machine, what you have to remember: plate process, uh, the rotary die process, aquagel process, bubble method. So these are the different machines available. So filling process and respective videos I will show you in the next class. Before that, I want to show you one picture. Just give me a second. I want to share. Mm,
Ma'am,
Yeah.
ma'am, why can't we use only soft gelatin only other than hard gelatin? Like if we are filling liquid semi-solids, why can't we use it for filling solid also?
All solids cannot be filled in soft gelatin. It is as gelatin is very soft. When you want to fill powders, powders are very fluffy. Correct? They when you want to put them in force, uh, the powder will try to come out or it will get adhered to the soft gelatin. So in hard gelatin, wait, I will switch on the video and I will make you understand. Say this is the capsule. Okay. I want to fill 2 gram of powder in it. Possible? 2 gram of powder in it. Possible?
Yes, ma'am.
5 gram?
Yes, ma'am.
5 gram?
Ma'am, maybe.
5 gram is possible?
Maybe, ma'am.
Okay,
Depends.
10 gram?
No, ma'am.
If industry wants to 10 gram in this, can we press the powder inside with the help of some pin? Press it, make some space and put the rest of the powder